Bismillahirrahmanirrahim and welcome to Research and Analysis. My name is Dr. Kamran. In today's video, I'm going to discuss how to use Smart PLS. If you are new to data analysis or even if you do not have any background in statistics, still you can easily learn this software.
You can easily download Smart PLS by using this web link smartpls.com. Smart PLS has two versions. One is student version and other one is professional version. Student version is free and you can use it for years, but it has some limitations, including it can only handle the data up to 100 respondents. You can enjoy the professional version, but only for 3 days. After 30 days, you have to purchase a license. But here is the good news. You can get 50% discount if you are a student or employee of any university or academic institution. I have this SPSS file for this tutorial, but unfortunately I can't use it in Smart PLS 3. In order to use this data, I will have to convert this file into CSV file. Although latest versions of Smart PLS can also handle SPSS files, but in order to use it in Smart PLS 3, I will have to convert it into CSV file. For this purpose, just go to File and from here you can click Save As. And in Save As, here you can see Save As Type. From here, just change its type into CSV and save it again. So this is how you can convert SPSS file into CSV file. Once you have collected the data, the first step is you will have to put the data into SPSS file, and once your SPSS file is ready, then you will have to convert SPSS file into CSV file, and then you will have to open this Smart PLS. This is the interface of Smart PLS. Then the first step in Smart PLS is you will have to create a new project. You can assign any name to this project, but for today's training, I am going to assign this project names as Smart PLS training.
Once you will create the project, then your project will be shown here. So we have created this project which is named as Smart PLS Training. This project consists of two options. One is for importing the data and other is for modeling. So first we will have to import the data. We will have to double click this option, and from here you will have to locate your CSV file. So this is the CSV file which we have just created. Double click and OK. So once you will click OK, the data will be imported here. So this is the data which we have just converted from SPSS to CSV. Here, good thing is you can also see some other things, like if you will have any missing data, it will be shown here. This is the mean, median, minimum, maximum, standard deviation, and you can also see skewness and kurtosis. So at this stage you can also assess the normality of the data. Although Smart PLS does not require the data to be normal, even if your data is not normal, you can still use Smart PLS. After importing the data, the next step is we need to prepare our model. For this purpose, we will have to select this option of model, double click, and now since we haven't created any model, so that's why it's just blank. In order to create the model, we will use these items. Since in this data we have 4 variables: self-sacrificial leadership, psychological empowerment, and job satisfaction, and finally psychological well-being. But in order to make it simple, I will only use self-sacrificial leadership, then mediator, job satisfaction, and finally our dependent variable or the outcome variable is psychological well-being. So first I will select our first variable, the items that belong to self-sacrificial leadership. So here are two options. In first option, I can press Control and then I can select one by one all the items. The second option is I can select first one, press Shift, and I can select last one. So ultimately all 5 items will be selected, and then in the second step I will just drag it over here. By default the variable is created with the name as latent variable 1, but we will have to rename it for our own convenience. Let's just name it as SSL. Now I will select our second variable, which is job satisfaction, and we are considering this variable as mediator. So I will select all 3 items of job satisfaction and drag it here, and again I will rename it as JS. And finally our outcome variable, psychological well-being, that consists of 8 items. Select all 8 items and drag it here, then rename it. Once we have all the variables here, then the next step is we will move these variables to the appropriate places. This is very simple. You can use this select option and you can move your variables at any place. You can also change the direction of these items. For instance, if I want to put it here, or here, and so this is how you can change your variables in a better or appropriate forms. If you want to have a better alignment, you can also use this grid option. In order to connect these variables, you can use this arrow, connect. That connect these variables. So this is how we can draw a mediating model. So let's make it a bit better. See, by using this grid option, you can align your project and you can make it in a better shape. Once you are done with this alignment, now model is ready to be run. And also, if you want to change the theme of this model, you can again select all, Control A, go to this more themes option, and from here you can select black and white and apply. So it totally depends on your choice. If you want to make them colorful, you can also do that, but if you want to make it simple, you can also do this way as well. So once your model is ready, now you are ready to run this model. For this purpose, just go to this calculate option, and from here just simply click this first option of PLS algorithm. Once you will click PLS algorithm, just click this factor option, the central one, and you can just simply go to this start calculation, just click it. So once you click it, now model is being run and you have all your results that are relevant with measurement model. Here important thing is, whenever you are running a model in Smart PLS, it consists of 2 steps. In first step is the measurement model, and in measurement model we come up with these results, including the reliability and validity kind of things. And in the structural model we come up with coefficients, and on the basis of those coefficients we actually examine our hypothesis. It's the same like whenever you are examining your data using AMOS, we normally use confirmatory factor analysis for validity things, and after that we actually run our model for examining our hypothesis. The same is the case with the Smart PLS. First of all, we will run it as PLS algorithm, and then it will provide us all these results. First of all, we will focus on this construct reliability, and then reliability we will focus on Cronbach alpha value, RHO, composite reliability, and finally the average variance extracted. I will not go into the detail because it's quite obvious the Cronbach alpha value that should be higher than 0.7, and the same is the RHO and the composite reliability, and finally we should have minimum value of 0.5 of average variance extracted to be which is threshold for average variance extracted. The good thing is with the Smart PLF is there is problem with your results, it will highlight those results with the red. As you can see, the Cronbach alpha value of job satisfaction is 0.6, so that's why it put the result into the red. So you can put special attention to these results. And then we have this discriminant validity, and in discriminant validity we have Fordner and Laken criterion, cross loadings, HTMT values, and finally we have collinearity statistics, inner VIF, outer loadings. So these are the things which we mostly focus on when we have results of Smart PLS. And yes, the final thing is the R square. So this is the first step in which we actually run measurement model. In the second step, we actually run our structural model. In order to run the structural model, just go again to calculate, and from here you can just simply click bootstrap. Here I will not go into the detail of the statistics, why we are using bootstrap and other kind of things. I am just telling you how you can use the Smart PLS and how you can get the desired results. Here you can use the bootstrap. Normally it is recommended as 5,000, so I am putting another 0 to make it 5,000, and PLS square, just simply click path and then click start calculation. So it will take a few seconds. Now we have the results of our structural model, and you can see all the relationships here, and this is the relationship between JS and PWB, and you can see the p value is significant. This is the coefficient value, SSL and job satisfaction JS, and here the beta value is 0.497, which is also significant. You can see the p value is 0.000. And finally we have the result that is representing the relationship between SSL and PWB, and this is also significant. In order to see whether our mediating hypothesis is being accepted or not, we will go into the result of this specific indirect effect. All this also provide us total indirect effect and total effect and so on, but we are only interested in specific indirect effects. So here you can see the result of our mediating hypothesis, and it is SSL, JS and PWB, and you can see this is the beta value and this is also significant. So now let me tell you how to present these results into your thesis or article. Once you're done with both the measurement and structural model, the result will be shown here. If we still want to go back to our measurement model, we can only click this. We only need to click this PLS algorithm, and we will actually move to our measurement model results. Here you can directly copy the result from here, and alternatively you can also export these results into Excel format. In order to export these results into Excel format, you can just simply you will need to click this export to Excel, and from here start export. We will have to provide the location. If we are okay with this location, just simply click save. So that the result will start exporting. See, now we have all the results of our measurement model in the Excel format, and we can simply locate all those results by just clicking the desired result or the option which we want to see. For example, if we are interested to see the construct reliability and validity, just click show, and you can see the results here, construct reliability and validity. Again, if we want to see any other result or the validity results, go back to navigation, and from here we can click our next option, the discriminant validity, show, and here we can see the results related to discriminant validity. So from the Excel format, it is easy to copy from. You can directly just copy and paste to your thesis or your paper. So next, let's also export the results related to our structural model. Click bootstrap and then export to Excel. Start export. Just name it as, we can name it as boot, and if we are okay with the location, click save. So the results related to our structural model are also exported into Excel format, and from here we can see the results related to our path coefficients, which you can see here. The coefficients, mean, standard deviation, t-value, p-value, and if we are also interested to see the intervals, so here you can find the lower and upper intervals as well. The rule of thumb is to examine the interval. If there is no zero lie between the intervals, which means the result is significant. But it's quite obvious. You can see also the p-value, and it will definitely show you whether your relationship is significant or not. Next, we are interested in specific indirect effects. Just click show, and from here you can see the result related to our hypothesis, which is relevant with mediation, the impact of SSL on PWB through job satisfaction, and you can see the result is significant. Now let me tell you how to present these results into your paper or thesis. One of my paper in which I have used Smart PLS. Well, this is the model, and here are the results. First, I have presented the results related to the measurement model, and I have just mentioned the loadings, Cron alpha value, RHO, composite reliability, and AVE, and where you can find all these results. Let's go back to our results of Smart PLS algorithm, and outer loadings, right? From here you can see the loadings of all your items. So these are the outer loadings. If you want to see the construct reliability, RHO, composite reliability, and average variance are extracted, all these results are given under this heading of construct reliability and validity. So this is how you can make your first table. And next we will have the table of discriminant validity measurement based on Forner-Laken criterion. And So these are the results of FLC, and you can just copy and paste in your second table. And here the important thing is you should understand why I have bolded these diagonal elements. These are actually the square root of average variance expected, and the rule of thumb is these values should be higher than the other values in the same row in order to establish the validity. So now you can see in each of the row this diagonal values are the highest. So based on these results we can conclude that there is no problem of validity based on FLC. In the next table we have the values of measurement of discriminant validity based on heterotrait and monotrait ratios. And you can see these values over here. You can just copy and paste it in your table. You could have fourth table of discriminant validity based on the cross loadings. And in order to locate the cross loadings, you can simply click the cross loadings which you can find next to FLC. So here are the cross loadings. So these are the things which you need to mention in regarding your measurement model. And next you will move on to hypothesis testing. For hypothesis testing table, you can rely on the results of your bootstrap, and from here you can locate the path coefficients and also your specific indirect effects. So these are the tables which you must add in your thesis or paper, but if you want to add more things you can still find in your results. And if you are following any particular format, so based on your requirements you can add all these things in your articles or your thesis. I hope this video will be helpful. If you will have any further questions you can write in the comments of this video. Thanks for watching.